standard deviation. It is the square root of the variance, and let's see, they give you these formulae to find it. It's basically the mean of the squares minus the square of the mean. So you would square all the numbers and find the mean of that, and then you would take away whatever the average is squared. That gives you variance, and then you square root that to get square root. We'll see what this looks like. Hang on, let me just copy this. Okay, so here's data, and where will I put this thing? I'll put it like that. Okay, so you have to find the variance and standard deviation for this data. How would you do that?
Okay, so do I have to get the largest and the smallest number here or something? Yeah.
Do you have to what, sorry?
Do I have to take the largest and the smallest number from the set?
So it is all of the numbers squared. So the average of all the numbers squared. So sigma x squared is what you get when you add up all the squares.
Yeah.
And then you divide that by the number of numbers, and then take away the mean squared and square root it.
So do I need to do square root of 3 plus 4?
So you'd start with 3 squared.
Yeah.
So 3 squared plus 4 squared. So all those squared. Plus 5 squared. And you get the average of those. So how would you get the average?
Divided by the number of the rows.
Yeah, so it says 7. And then you take away the mean squared.
Okay.
So in a bracket, all those added up, and then you square that. It's 5. That's over 7 squared, and then you square root that whole thing. So okay, calculator time. My simple calculator, I bought the license for it, but I think their server isn't working or something. I don't know if it's because of the COVID-19 stuff, but so I have to use this advanced calculator, and I don't quite know how to do it. So 3, 4, 6, 2, 8, 8, 5. I want to do.
Sorry, how did you get to that list there?
Menu 2, I believe. Menu 2 for statistics.
Yeah, sure.
Is
that on the graphical? That's on the graphical, isn't it?
This is graphical, yeah. If you're using the simple, which one are you using?
I've got both here, so I'll just use the graphical.
Okay. So I'll put those in.
Yeah.
I think if I put in a frequency of 1 for each one. So you might not have to put in frequency. I was messing around with this. There we go. It does work. So did you put those in? 3, 4, 6, 2, 8, 8, 5?
Yeah, I'm just looking now.
So then you choose calculate, or you might have to press option first. Or
yeah.
So calculate, and we have one variable, so that's one variable. F1, sorry.
Sorry, so did you press so you press calculate?
Yeah, and then it's one variable, so F1. Do you have that?
My calculate goes to solve dx, d squared x, etc.
Press exit.
Yeah.
So does yours say calc here?
No, my calc is a F3.
Uh, F. Uh, let me see. Um, Press exit again.
Yeah.
Does it have calc?
Yeah, now it's in in that spot. Yeah, yeah,
Okay. Yeah. So F2 one variable,
yeah.
and you
Oh,
get
yeah. Thank you. Yeah,
that screen.
yeah,
Okay. So it tells us the average, which is x bar. So that was this one here. Minus 5.14 minus 5.14 squared. Let's see. It tells us sigma x, so that's what you get when you add up all the x's. So that's helpful for finding the mean. It tells us sigma x squared, 218. So that would be the top bit. Oh, it's a big square root. So that would be the top bit there, 218. That's over 7. Uh, this one, and then helpfully, that's the other one. If I press down, press down Q1 mod. Does this one? Is it SX? Is that standard deviation 2.34, or is it a D? Delta X 2.1665. Let's take a look. 2.17 rounded. So it's the DX. Delta X is the standard deviation there.
yeah.
And so, yep, that's where it comes from. If you have to show you're working out, you can do, it has to be, so you can see there sigma x squared. So we have sigma x squared, n is 7, sigma x was 36 and 7. And so
Yeah.
that shows you're working out. So square root 218 over 7 minus 36 over 7 squared, and that gives you 2.17 roughly. Any questions about that?
No.
Okay, so and interquartile range shows you how spread out is the middle 50%. Standard deviation takes all the data into account, just like the mean. It takes all the data into account, but the problem is it might be affected by an outlier. So if there's an outlier, you might use interquartile range. If there's no outliers, you would use this. Sometimes it has a frequency, but you just do the same thing with the frequency. So it's the frequency times the x squared, and you do it that way. Let's try this just pure calculator. This time you have a frequency. And actually, hang on, let me help you. So in your one, if you go back to the table, do you see set on F6?
Yeah, yeah.
So is your one variable frequency set to 1? Your second?
Uh, yeah. I think I've got the same thing. Yeah. Oh no, no. My one VR frequency is just one.
So I'd press F2 for list and change it to list 2.
So do I just put so I just put two into the yeah. I've got list two now, and also for my two var frequency at the bottom, it's one. Should I change that to list three as well?
You can. That's two variable stuff. Okay. That's for a different topic. So like regression and stuff. Yeah, I set mine for list 1, list 2, and list 3 for that one.
Okay, yeah, I think I'll put the same one now.
And then you press exit when you've done that. The little trade-off though is in my one, my list 2, I had to put in 1 for everything for the previous one. Otherwise it just didn't work. Okay, so for this one, your list 1 is the x and your list 2 is the frequency.
Okay.
So try that. Oh, I have to delete my other. Oops, no. And so tell me when you've got that. Try the one variable thing.
Okay. So now, do I just have to like press exit twice and then press calc? Or,
Or yep, just find that one variable thing for F1.
oh yeah, yeah, I've got it here. Yeah.
And so, what is standard deviation?
Mine's 0.86. Yeah.
Yeah, 0.861. So 0.861. So delta x equals 0.861. And there it is, 0.861. So they did the same as the previous question, except it was everything times the frequency. So the way you would find the mean in GCSE, like 3 times 35 plus 17 times 36 plus 29 times 37, they did all that. So they did the mean doing it that way. Any questions there?
No.
Okay. And as far as I'm aware, the exam questions explicitly say use your calculator to find the standard deviation, just so people don't try to find the long way. Okay, how about this one? How do we do this?
Do I need to now put the length of the cell phone call like at midpoint
Yep.
for each one?
Mm-hmm.
Okay. And then with the calc, do I just put, so for the list one, I put in all the midpoints, and then I just put the frequencies in after?
Yep. So what's midpoint for the first one?
2.5.
Yeah. So just do all that then. 2, 5. And if you're not sure of the midpoints, like 20 and 60, you can just do a bracket 20 plus 60 close bracket divide by 2. So you can actually just calculate it in the thing and it just comes up 40. So it's obvious it's 40, but sometimes it might not be obvious. Just in case. And then frequency. What you do for frequency?
We just put the frequencies alongside the midpoints of the things.
Yeah, you don't have those or anything. And that one has frequency of 0. Nothing wrong with that. It's just 0. It's kind of weird that they'd put 0, but yeah. No, I suppose it's not weird. Yeah, you want a table. And so, standard deviation for that one.
I got 11.4.
So that one is 11.4. What is the mean length of telephone call?
Is it 10.6?
Yeah, 10.6 minutes. Yeah. How many phone calls were made?
I'm gonna guess 27.
Yep. And that was what you'd get if you added up like 4, 50, and 5. So sigma x squared is what you would get if you added up the squares of all the midpoints. I think Sx is sample standard deviation. We don't need to worry about that right now. And it gives us an estimate of lower quartile, median, upper quartile. It tells us, yeah, but you can see it's just it's not linear interpolation. Oh, there we go. Okay, so it was 11.35. Is that what we said? For standard deviation? Yeah, 11.35, 11.4. Great. Any questions about that?
No.
That's good. So this is the stuff that we have to watch out for. A lot of the time they give you excuse me, they summarize the data down for you, so they don't give you raw data, they give you summary data. How do we do this?
Is this like part of the formula from before?
Yeah, and I believe they give you the formula.
So would that be like 5,905? Oh no, square root of
Mm-hmm.
1,905 over n minus,
Hold on. What is n?
sorry, 10
Yep.
minus, oh right, and then brackets 241 over 10
Mm-hmm.
squared.
Yep.
So
Try putting that in. Oh.
I got root 969 over 10.
Root 969 over 10. And what is that? 3 sig fig?
Oh, sorry, it's not. It's it's square root 969 and then divide that by 10. Sorry.
Okay, so that.
Yeah.
Okay.
And just that's 3.11.
So that's 3.11 kilos. So that is the spread. So that's their how spread out they are. 3.11 kilos. Oh, I don't have the answer, but I'm sure it's correct. I think that's good. Yeah, so sometimes you have to use the formula, and you see this thing up here,
Yeah.
SXX. So this bit at the top, sometimes they add these two together. That SXX is just the top bit after you've put those two fractions together. That's over n. Let's see. Use a calculator to work out the mean and standard deviation. Compare the two. All right, we'll do one. Okay, let's do this.
So do I just need to put that into my calculator?
Yep.
Sorry, did you say do B or do both? Sorry.
We'll do both. We'd have to do
Yeah.
A to do B.
Okay. Um, my mean is 6.558.
Mine is 6.6769. Let's go back to data. Are your number of ladybirds 5, 6, 7, 8 and frequency 11, 15, 23, 16?
Sorry. Um, I've got the same. Yeah, I've got the same answer as you now. I just made a silly mistake.
Okay.
Yeah.
Okay, let's say to 1 decimal. No, we'll do 2 decimals. So the mean is 6.7. Yeah. So X bar 6.7 ladybirds. And the standard deviation?
is 1.024.
1 point. Oh, so it goes 1.02. Okay, question B.
Okay. So I just want to ask quickly, what does standard deviation actually mean? Sorry.
It's a measure of spread, so it's how spread out the data is.
Okay, so is it like the higher the standard deviation, the more spread out the data is?
Yeah, it's
Okay.
like a fancy range, something like that.
Yeah. Okay. Um. So would you say something like um that there were more ladybirds 2 weeks later than there were now,
Right.
and like there was like a wider range of different ladybirds now than there were in 2 weeks later.
Yeah, but the number of ladybirds was more spread out.
Yeah.
Ladybirds. Let's say it was more variable or something. So yeah, so on average there were more ladybirds on each bush, but it was more spread out. So although there was like a higher kind of maximum, there's also a higher minimum type of thing. Let's see what they said. The mean number of ladybirds is higher on the second day, but there was less variability. Hold on. The gardener repeats. Let me go back. So the standard deviation is 1.02. The gardener. Sorry. It's it's the other way around. So the gardener repeats the count of ladybird 2 weeks later. So 2 weeks later, the mean had increased, but the standard deviation had decreased. It went
Yeah.
from 1.02 down to 0.94.
Yeah.
Yeah, so more ladybirds 2 weeks later, and there was actually consistently more.
Yeah.
And the number of ladybirds was less variable, so it was like consistently more. So it was more variable 2 weeks ago. Okay, any questions about that?
No.
Yeah, so it's just like comparing average and spread. I mean, it is literally comparing average and spread, just a different average and a different spread. So you can see there, part A, use your calculator to work out the mean and standard deviation. How many students? Oh, okay. Let's see this one. Let's go. I'll use that one. So this one says, part B, how many students received an amount of pocket money more than one standard deviation above the mean? Let me just see something. Oh, I don't have the. Why don't I have the answer for that one? But I do for the other one. Let's see. So this one, how many ladybirds received? How many ladybirds were more than one standard deviation above the mean?
Sorry, can you repeat the question, please?
No, I better do this one. Okay, we'll do part B for this one, and I'll quickly try to work out part A. So any idea how you do part B?
Would you like put the data into your calculator, and then after that, I don't know, see what the standard deviation is, and then
So mean is roughly 10. Standard deviation is roughly 1 and 1.34, 1.35.
yeah.
Okay.
So then So when this is more than one standard deviation but above the mean, is that like 1.34 plus the mean, or
That is, I believe so. Yep.
so?
Yep. So what would you get? Mean plus one standard deviation.
You would get about 11.5.
Yep.
7ish, yeah.
How many students got more than 11.5?
20.
It is 20, and number of pounds. Yeah, it's about 20. X bar plus standard deviation is £11.50. And so how many got more than that? So it's approximately 20
Yeah.
kids. Yeah, that's it. What if they had asked? No. Yeah. What if they had asked how many kids got one standard deviation less than the mean? Less than one standard deviation less than the mean.
Would that just be like 10.22 minus 1.349?
Yeah. So that would be 8.9, something like that.
Yeah.
So what would that be?
That would be 8 plus 28 plus 15 plus 20.
Less than that.
So 14.
Yeah, exactly. And you could do the same for this one as well. Okay. Any questions about that?
No.
Okay. So use a calculator to estimate mean and standard deviation. 80% of his rounds. Oh, we better do this one as well. Okay. Question. Oh. Let me see. Yeah, how do we do question B?
So I need to put this data into my calculator, don't I, and then see.
Yeah. So, what would you put in for the first time?
4.25.
Yeah. So 4.75, 5.25, 5.75, 6.25, and one variable. That's what it looks like. Okay, how do we do part B?
So would that be 100? Oh no, would that be 5 plus or minus the standard deviation time?
Well done. So that was 5. Delta x was 0.54. And so it is 5 plus or minus 0.54. So I'll let you work that out.
So that'll be 4.46 and 5.54.
5.4. And what is next?
I now need to basically see how many of these like numbers here fit into that category. So would that be from like 5.5 to Would that be from the fourth set to the first set of times?
So what frequencies would it be?
5, 7, and 8.
So 4.46 is nearly not in that one. Okay, so what would you get for that?
21.
And
20, sorry.
is that 80%?
Nah, that'll be more.
So it's slightly more, is it? So that's that makes 15, 20, 24. So it's slightly more. 20 out of 25 will be 80%. So 20 out of 24 is slightly more than 80%. Let me just see something. One standard deviation from the mean gives that and that, which gives a frequency of 15 inside the interval. This is only 16, so it's wrong. 4.46 to 5.54. I thought so. So 4.46. It's technically in there, but it's just at the edge.
Yeah.
And then 5.54 is definitely most of this one, but it's almost none of this one. I think yes, they rounded this data to 1 decimal place. So if we were to round our one to 1 decimal place, we'd get 4.5 and 5.5.
Right, yeah.
And so it's like, what data is in between 4.5 and 5.5? This 4.5 isn't included, but this one is less than or equal to.
Yeah, okay.
And so it's rounded data, and so we're just going with the rounding. Ooh, that was a tricky one. So any questions about that one?
No.
So we have to round our data to be the same as their data. Okay, makes sense. But other than that, let's see this one. Use your calculator to work out standard deviation. That's easy peasy. I should move that. Hang on. Move sooner. Move back. Oh, hang on. Is it easy peasy? Oh, it's got 0. I suppose that's a bit weird. But no, it's fine. Yes. How do we do this one?
So, do you have to make it into like some sort of equation, or
Okay. And it tells you that the variance is standard deviation squared.
okay? So the variance is so the standard deviation squared is equals to 7 and 6.5, or
Standard deviation will be root 7 for the first one, root 6.5 for the second. But the answer asked for the overall variance, so I don't think we need to do anything with standard deviation. I might be wrong. Let's start with mean.
yeah. I'm a bit confused, I think.
Imagine there's no variance.
Find the mean of the combined set of 11 numbers.
Yeah. So 6 numbers have a mean of 5. 5 numbers have a mean of 5.5. What is the overall mean of all 11 numbers? How would you do it?
5.5 plus 5 divided by 2.
You fell for the trap. You didn't fall for it last time when there was no variance. Basically, the mean is you add up all the x's, divide by n, and you get, that gives you the mean. And so what are, sub in the values for the first one.
So, so 6 numbers. So would that be like something x over 6 is equals to 5, or
Yeah. And so what is sigma x?
30.
And so now let's call the sigma y.
So now I need to do. Oh, right. So that divided by 5 is equals to 5.5.5, and then do 5 times 5.5 to get sigma y,
Yeah.
and that's 27.5.
Okay. We now want the overall mean.
Do I now add them up together and divide them by 2?
You don't divide them by 2. That would be if there was two. If there was two values.
So
How many numbers are there altogether?
2.
No.
I know. Is that just 27.5 plus 30?
So that was going to be, 30 plus 27.5.
So
And what will we divide it by? And remember, it's not 2.
is that 11?
It is 11, yeah. It is
Yeah.
6 plus 5.
So
So what do you have for that one?
I got 5.227.
Okay, I say 5.23. Yes. So you have to reverse to get the total x's, like total of the first one, total of the second one, and then do the new mean, adding those up. We did this one lesson ago and you got a first shot. I think it's because you've got this variance stuff going on that threw you a bit. Speaking of which, now let's try something similar with variance. So 5.23 for mean. We got it. 5.23. Let's try something similar. Variance.
So shall I just block out the variance again?
Well, this time we want variance.
Okay, but so I shouldn't. So do I need to find standard deviation and then just square root it?
Standard deviation would be root 7. Standard deviation would be 6.5. Standard deviation is square root of variance. So variance is standard deviation squared.
Okay. So
what is standard, using this formula, what is standard deviation squared? How would you do that?
Would I first of all need to add up 7 and 6.5?
I don't think so. Let me see. So standard deviation, the one we've been using is the one in the middle. Sigma x squared over n minus sigma x over n squared. So the first one is just kind of where it comes from, and then the third one is for summary data SXX. What if you squared both sides? What would you get?
You the square root sign go.
Yeah. And so the variance would be equal to sigma x squared over n minus sigma x over n squared. What is, let's say, what is n?
11.
So n is 11. Do we know anything else? And this was what we did before.
So when it uses
What does sigma x mean?
when I add up all the numbers in the set.
Yeah. So what do you get when you add up all the numbers?
11.
That's n.
Is that when I did like 30 plus 27.5?
Yeah. So that one is 57.5. That is 57.5 squared. And now we just need sigma x squared. How do we do this?
Is that 57.5 squared or?
I don't think so. I think that would give us 0. You have to square. Let me just see. Is it using SXX? So 6 numbers have a mean of 5. So their variance is 7. Oh, hang on. Let me. So one variance is 7. One variance is 6.5. I think there might be a simple way to do this. Because we have just summary data, so we don't have the raw data to do that. There were 6 numbers and they had a variance of 7. So 6 times 7 plus 5 times 6. And that's over 2, 36. 6.83. Not sure how they're getting that last bit. Oh, did I put it in right? 6.5? No, I didn't put it in right. 6.5. 6.5. Is a square root of that? 37.25. I don't think so. I don't know how to do SD. Okay, let me leave that one. Just want to see if there's something similar. This one, I forgot the question. Find the mean and standard daily thing. That's okay. Use your calculator. Mean and standard deviation. What was that? Estimated number of days was greater than one standard deviation above it. Yeah. Okay, so there was no other question of that one. So I'll leave that one. I don't know how they did it though. Without so with the mean, you can just kind of go back to the raw data, sigma x. I think it might have something to do with the SXX.
Yeah.
Combining those two. Hang on. Sigma x squared. No, I think it might have something to do with that, but I don't want to mess around with it if it's just one weird question that they're throwing in there. So it was the only one that's like that. And let's see, number of days in which the wind speed was greater. State 1 assumption. Yeah, we did that. Standard deviation. Okay, variance and standard deviation. What do you give yourself there?
I think a half.
Okay, so I just want to see. Coding is the last thing. We can take a quick look. Okay. So coding is a way for them to simplify the data a bit. So they might multiply everything. So if everything is a decimal, like the 2 decimal places, they might multiply everything by 100 just so it's not a decimal anymore. You'll see. So here.
What was the formula? Sorry, what was the formula? Sorry.
So there's no formula as such. You just have to work in reverse from the data. So these are the x's, and you have to code the data using. So they have to give you what formula they used each time.
Okay.
So these are the x's. So what do you get if you? What is the y for each of those? If you sub it in.
So for the first one, would it be 3.2?
Yeah.
And then 5.5 and 0.6.
Yeah.
I'm guessing it would be 1.7, 0, and 4 after that.
And 4, right, it's 4.0. So it's just a way to simplify the data down a bit. Then you then find the mean and standard deviation of this data. So how would you find mean and standard deviation for this data?
What I put my calculator?
Yeah. And what do you get?
So do I need to put the frequency as 1 for each one? Is that not necessary?
Correct. Yeah. Because we put in the frequency, we changed it from 1 to list 2. You have to put 1 for each one of them. I think it's better to have it like that, so you never have to change it.
So I got. So for the mean, I got 3, and for standard deviation, I got 1.72.
Okay, so 3, 1.72. And part C.
Um,
Any idea how you do C?
no.
So what would you get? So you basically do the opposite now. So what would you get if you made it x equals in the coding?
Uh, X equals to 10y plus 300.
Yes. And so this, uh, these are like your y's, and so you sub that in. So it's times by 10 and then plus 300.
Is that for each? Do I do that for each set or just?
Uh,
Oh,
just for the average and standard deviation.
so do I need to first of all find the average of all these temperatures here?
So we just found, so the coded average is 3. The coded mean was 3. And so you times that by 10 and add 300.
So that'd be 330.
So that would be 330. And any idea what you do for standard deviation?
Square root it.
So I think you would just, it's the same idea, like times by 10 plus 300. So you're just undoing what you just did. However, I think you just times it by 10. And that's because if you move it from left to right, it doesn't actually change how spread out it is. Standard deviation is that one. Yes, I believe the standard deviation. So if you times it by 10, 17.2, it's spread out 10 times more. But if you move all the data left or right, it's still as equally spread out. So if the temperatures all increased by 5 degrees, then they're all still the same spread that they were before.
Yeah, yeah.
Yeah, I'd help anything. So this is what coding is. So you, instead of having like this hundreds, they just boil it down to this. They put it through some code. So just boil it down to these little simple numbers. They found the mean of those, and then they uncode it to get the actual mean.
Yeah.
So we'll just try. Let's see. So this is. Let me see this one. The data was coded. So, hang on. Also, they tend to give you the coding. Okay. Okay. Now let's just stick with what it actually is. This one. Man, this isn't easy. Okay, so how about this one? They give you this SHH. They're using H instead of X. Same idea. H bar.
So do I need to substitute? Oh no. So do I need to do something like um there's no like data for me to use my calculator, is there?
No, they've already done all that. So they said H bar is 2 and H is a coding of the raw data. So they had like the raw data, they subtracted 5 and then divided them by 10 and found the average of that, and they got 2. So now we need to find the actual average of G.
Right. Um, would I have to start off by making G the subject,
Very,
or
very good. Yep.
would I then do 10H, G is equals to 10H plus 5,
Mm-hmm.
and then um, hmm,
So you have to go from the coded mean to the actual mean.
so do I need to make 10H plus 5 equals to 2 or something, or
You need to. This is H, not G.
yeah?
So you don't sub it for G, you sub it for H.
So do I do G is equals to 10 times 2 plus 5?
Yeah.
So G is 25.
Yeah. And so they had a bunch of data. They summarized it down, and now you're just uncoding it.
Yeah.
In the same way that we did it here. So we had this kind of weird data, like this up in the hundreds and stuff. We boiled it down to just simple numbers by putting it through some code, it's called. And then we just uncoded it back by doing the opposite, by multiplying by 10 and then adding 300. And actually, you're right. This formula, they just do a linear code. So they just always add or subtract something and divide by something. So it's always going to be that at A level. So there's nothing more complicated than that. I just want to do one more. Let's do this one. Exam question.
Do I need to make X subject now?
Uh-huh.
So would that be that X is equals to 200Y plus 65?
Mm-hmm.
And then and then make do X is equals to 200 times 1.5 plus 65.
That's it. What is that?
That is 365.
So y bar is 1.5, x bar is 365, and I think it's pound. And yeah, and so I just threw that in, but you did great with that one. The only trick is when you are uncoding the standard deviation, what would be different?
I need to. Oh, does Y need to be Y needs to be the subject for that one?
No. So for the mean, y is equal to x minus a over b. So x bar is equal to b times y plus a. For the standard deviation, The only difference is you don't add the a. It's just times by the number. And that's because adding or subtracting the same amount to all the data doesn't actually change how spread out it is. So if everyone gets an extra £10, the data is exactly as spread out as it was before. So the average goes up by £10. So the average will change, but the spread won't. Any questions there?
I don't think so.
So we might just take a quick look at that next time because I threw it in, but that's this chapter done then. Just want to take a quick look. Sorry, I'm keeping the extra measures of spread. So measures of spread, before it was interquartile range, interpercentile range. That matches up with median. And then variance, you'll notice we were always finding mean and standard deviation. Those match up with each other. Standard deviation is square root of variance, and variance is the mean of the squares minus the square of the mean. Calculator can do that, and we have a setup now to do it easily with raw data. We have a setup to easily do it with frequency. This one, midpoints, that's okay. So sometimes they give you the summary data, so you just have to sub it into the formula that they give you. Mean of square minus square of mean, and then you square root it. Most of the time they say use your calculator to find the mean and standard deviation, and then you're just comparing it the normal way. You're comparing averages and you're comparing spread, and so the less spread out it is, more spread out it is, higher, lower. This one, yes, how many were above this one standard deviation? You just do mean plus one standard deviation. How many are more than that? Or it might be mean minus one standard deviation. How many are less than that? Something like that. This one was plus or minus standard deviation, so you did that one. That was great. And this one, we need to round it to one decimal place, so we need to round it to what they rounded it to, and then we just show, that's those two. This one was easy peasy. It had 0, just put in 0. Nothing wrong with that. Let's see, this one, yes, you have to unfind the mean for both of them and then find the new mean for all of them. So you're okay with that one. The variance one, I don't know how they did this. I'll have to see that, but they just threw in some one weird question. I'm not losing sleep over that one. This one was okay, just put it in the thing. That one was just more formula. And then coding, yes, they put it through some code to make all the data smaller. So you can imagine if there was loads of numbers, instead of having them in the hundreds or thousands, they just have little small easy numbers. They find the mean and standard deviation of all the easy numbers, and then they just uncode it. So times by 10 plus 300. How is decoding standard deviation different from decoding the mean?
Because wasn't that for standard deviation? You just substitute it in rather than doing the subject and that sort of thing.
So you know how we did for this one? We did times by 10 plus 300.
Yeah.
So for mean, it would be times by 10 plus 300. For standard deviation, it's just times by 10.
Okay.
For this one, we did times by 2 plus 5. Standard deviation would just be times by 2. And it's because adding or subtracting doesn't change the spread. Yeah, they should show that. But then we did exam question. There might be some, I'll take a look at these exam questions, but I think they're all going to be similar. We need a bit of extra practice, but that's all right. How was that for you, Andrey?
That was good, thanks.
So next time, if you want, we can move on to next chapter.
Yes, please, yeah.
Okay, great. Any questions for me in general?
No, I don't think so.
All right, well done, Andrey. You did great. I look forward to chatting again next time.
Okay, thank you. Bye.
Have a good one. Goodbye.